All right, shut up. So, let's talk about modeling. So, I bet somebody thought that was funny. So, we talk about modeling, talking about how nouns relate to each other. So, somebody give me an example of a noun. Car. Cool. So, you might say that one car has many drivers. Each driver can have many cars. That would be an example of a data model. So trying to figure out what the concrete things are in our application and figure out what their relationships are to every other concrete thing. So by the end of this lesson, I hope that you'll be able to diagram one-to-many relationships and diagram many-to-many relationships. This isn't just my shit handwriting. This says M to N. That is the correct way to say many-to-many. It's a math thing. So I'll skip to the end. This is what the diagrams look like. I might say that, so I'm a person, and I have many shoes. They say one person has many shoes, but each shoe only belongs to one person. That's a one-to-many relationship. Let's dig into that a little bit more. What I think is tricky about one-to-many relationships is one-to-many, that makes plenty of sense. The thing that people screw up is trying to read that backwards. One person has many shoes, and it's not, and many shoes have one person, or something like that. You'd say each shoe, every example of a shoe only has one person. So if I'm diagramming, if I'm trying to come up with examples of this, I am currently wearing a stylish set of Zelleros. So Kyle's a person, and Zellero is a shoe that we'll say is owned by Kyle. Elise, also a person, and what are those like? They're really popular with women right now. They're like canvas shoes. You can put them in the washing machine. Toms? Not Toms. They look kind of like Toms.
Bobs?
We're in the ballpark. You can put them in the washing machine. They're like one step fancier than Toms.
Oh, Rothy's?
Rothy's, that's it.
I was like trying to remember the Instagram ads in my brain.
Yes, that's exactly it. So the Rothys are owned by Elise. But they can't be owned by Elise and Kyle. They only be owned by one person. And we could say, that's another pair of shoes I have. I have some Skechers. And the Skechers are owned by Kyle. So each one of these names can show up multiple times over here, but each one of those only gets owned by one person. We call that a one-to-many relationship. Questions about the concept of one-to-many relationships? Seems pretty straightforward, right? All right, let's practice. So let's say I have, I got to think of some. Room and building. I want you to think to yourself for a sec. What is the relationship between room and building? I'm going to call on somebody. This is going to be a one-to-many relationship, but I want you to think about which one's going to be one and which one's going to be many. Think to yourself. Katie, what do you think?
Building has many rooms.
Building has many rooms. And can somebody else tell me what the inverse of that is? So one building has many rooms and each room only has one building. That's how we do that. Let's see. Joe, how would I diagram this relationship? Same way that I did in the other ones.
Yeah. The room would have the many line around, so I guess
Tell me what to draw.
square around each one.
Okay.
Line connecting
Okay.
one on the building side and many on the room side.
Perfect. Good job, everybody. So this diagram is called an entity relationship diagram. In the industry, we just call them ERDs. This is an entity, this is an entity, this is a relationship, and it's diagrammed. Pretty straightforward, right? Questions so far about this concept of ERDs, one-to-many? Okay, let's go one step more abstract. We have an event like a meetup or a conference, something like that. And we have organizer. Think about how you would complete the diagram on this. Event and organizer. Damon, what do you think?
I think you could go a couple of ways. That an organizer could have many events.
Okay.
Also, if you think about meetups, like events can have many organizers.
They can. So the thing I want to highlight with this is that we have to make the rules for our app. It is conceivable that an event has more than one organizer, right? It's also conceivable that, there's always a lead wedding planner. That's the person we have on there. What other people they may use, that's their business. So you need to make a choice about your app. Does your app support more than one organizer for an event? Or does your app support only one organizer has many events? All right, I want somebody to tell me the directions on this. So, let's just say one organizer has many events, and the inverse of that is, wait for it. Cat, what's the inverse?
Each event has one organizer.
Each event has one organizer. So this seems all well and good in the classroom, but you will run into a point where like, no, it just sort of makes sense because one organizer has many events and many events have one organizer. It's like, I'll say each event has one organizer. Cool. Seems pretty straightforward, right? So that was, believe it or not, our first objective here, modeling one-to-many relationships. So now we're going to ramp it up a little bit. We're going to talk about, let's do blue. Oh, I already did that. Green. Yeah. Darker green. All right, so let's talk about many-to-many relationships. Let's start with that example where with the events and organizers. So this is Develop Denver. Develop Denver is an event. There's 13 people on the organizing committee for that. So just based on the context we've seen so far, I want you to think about how you might diagram that. Think to yourself. Gauge, what am I doing?
For many to many.
Mm-hmm.
You create a box in the middle.
Mm-hmm.
Connect.
Ooh, you're skipping ahead. I like it. Okay, so make a box in the middle, then what do I do?
Connect the events to that box and that box to organizer.
Okay. And then what? Let's put a pin on this. We're going to come back to it. Someone else, give me the simple way that we would model that. Yeah.
So with the event and the organizers, you would draw a line to connect those two.
Mm-hmm.
And then you have, so it's many to many, so you can have many organizers and many events.
Yeah.
Just like that.
By the way, in the business, we call these crow's feet for obvious reasons.
What do you call them?
Crow's feet, because they look like crow's feet in cartoons. There's a few different ways you can diagram these relationships. Chen notation is the other really popular one. Crow's feet is what we're going to use. And I think it's just like the easiest to kind of intuit your way through. So yeah, we would say that one event has many organizers and one organizer has many events. That's how you pronounce that. Kind of the same with our inverse. We'd say each event has one organizer. Each event has many organizers. Each organizer has many events. So, as for an example, we would say Develop Denver is an event. Kyle is an organizer. So is Scott and Gabby and Kim and Michael. And so you might say something like, Kyle owns Develop Denver, but Scott owns Develop Denver and the Happy Hour. Gabby owns Develop Denver and the React Meetup. Kim only owns Develop Denver. Michael owns Develop Denver and the Happy Hour. Questions about this many to many? this correctly. Should also put the happy hour as an event and the react event. I have these instances of the event entity, these instances of of an organizer, and then this is their relationship. More complicated because they can have more than one. And really, we can do that from the other side too. We can say DVLP is owned by Kyle, Scott, Gabby, Kim, Michael. Happy Hour is owned by Scott and Michael. React is owned by Gabby. So, with databases, we actually can't model this way. Doesn't work. What we need is an entity in between these. We call this a join table. And what it does is this just becomes DVLP, happy hour, react. This is Kyle, Scott, Gabby, Kim, and Michael. And instead of organizer or event keeping track of who owns whom, this join table keeps track of them. So what we'll have here is a record for DVLP and Kyle, and DVLP Scott, and DVLP Gabby, and DVLP Kim, DVLP Mike, then React, Gabby, happy hour Scott, happy hour Michael. So every coincidence of event and organizer is kept track of in this join table. Anybody remember from last Tuesday what naming convention we used for the join table if we couldn't come up with a better one? Environment? That's a good guess. Environment is what we use to mash together all the classes in Ruby.
Was it dog park?
It was dog owner or something like that.
Don't we just mash the two classes together?
Exactly. These aren't classes, these are entities. Same kind of idea. And we did the same thing with classes. So we call this an event organizer. So event organizer just keeps track of every time an event has an organizer. Still need to put our crow's feet on the second version of this though. I want you to guess, hazard a guess at where the crow's feet go in the join table. What you got?
One event has many event organizers, and one organizer has many event organizers.
Correctamundo. So that's a one-to-many. That's a one-to-many. All right, if this all just makes sense to you, I'm gonna be really upset because I got a degree in this. So what questions do you have about data modeling, one-to-many relationships? Yeah.
I guess I just have a question about like when do you use these diagrams? Are they just
Mhm.
for you to like kind of keep all of your data like on track in your mind, or?
Absolutely. This is one of the first things that I do when I'm trying to understand a problem. And once you like kind of cotton to data modeling, you sort of can't stop doing it. And you just sort of start seeing everything in terms of how they're related to each other. So, Ahmed, since you're in the room, what's your crapstone? Okay, so give me some entities from your game. Okay.
Player.
And a player doesn't have to be a user?
Does have to be a user.
Okay. Cool. Give me some more entities.
Player's got a weapon.
Okay.
And we'll throw accessories on there for switch.
Okay. So I'll look for these nouns when I'm trying to understand how an app works or how an app that I'm going to make is going to work. All right, so user and a player are the same thing. That means that's a one-to-one relationship. That's how you say these are equivalent, basically. But you might be able to keep track of different things on each of these. This might be username and password. This might be number of points, for example. All right, so let me say a player can presumably have many weapons. Is each weapon or each instance of a weapon, is that exclusively owned by one player?
Yeah.
Okay, so more than one player can have the same weapon. And so that means join table on player weapon. Okay, what about accessories? Is that the same thing?
Yep.
Okay. And so that's an example of how, like, you hear how we're trying to figure out the rules of this game this way? Because you can imagine a world where all the weapons are exclusive, and once a player has one, it's not owned by anybody else. You could also imagine one where it's like, sword. Well, silver sword. Multiple players can have the silver sword. So then we need an instance of each player who has a silver sword. So this is one of the first conversations I'll have with somebody when I'm trying to understand their problem. Because the next step with this is I might go, all right, well, how do I represent this with classes? Or how do I represent this with another programming tool like that? Because a lot of the times with classes, it's just a one-to-one. All of your entities become classes. That's not always the case, though. But this is going to be that long-term storage for my application. And it has been my experience in software development, if you get this right, the rest of your app development is pretty easy. You get this wrong, you end up doing programming gymnastics trying to make up for modeling it incorrectly in the first place. For example, imagine, since user and player are the same thing, let's imagine another world where we modeled them as not having a relationship with each other. And you end up with something like users have weapons, but players have accessories. Okay? So you go, okay, you can only get this weapon if you have a certain accessory equipped. Uh-oh. So then you need some kind of weird programming jankery to find a player that has the same something or other as a user and then navigate through that to get to their accessory and then bring that back. Yikes. If you just understood how those things were related in the first place, you would have a much easier programming task ahead of you. More questions about Many-to-many relationships. Yeah.
I was trying to like imagine, like, say a weapon in that game.
Mm-hmm.
Is that weapon an instance, its own instance? There's only one instance of it always.
Ooh, it's a good question. If I have Silver Sword, is that a weapon or is that an instance of the weapon? So we think maybe Silver Sword is a template. So maybe that's weapon template. And that can have many weapon instances. So this is Silver Sword. This is Silver Sword in Kyle's game right now. And this indicates whether or not Kyle has it.
What was the top one that you wrote?
Weapon template. So this one might be Silver Sword and it has 4 attack or that kind of thing. This one might be cool. It's called Silver Sword and it's got 4 attack, but this one is Silver Sword in Kyle's world. So that might exist. Think of like Terraria or something like that, or Minecraft, where there's a template for what Silver Swords are like, and there might be 10 of them in my world, and I might have 3 of them in my possession. That's data modeling.
So 10 instances of it?
Sure. So if there's only one Silver Sword, like there's not another Silver Sword that has 5 attack and one that has, something else. So that's the template for it, but I might have a bunch of them populated throughout my game. But I might only have a couple of them. So that's where each of those different things is going to be stored. This is what a Silver Sword's shape is. This is keeping track of the coordinates in the world that they're located in my game. This indicates whether or not a particular user has one in its possession.
That's why everyone goes into game development and then they become programmers.
No, people go into game development because they're like, hey, I like video games. What if I did it for a living? And then they get there and yeah, there's a whole bunch of other people that thought that exact same thing. So we're going to pay you negative dollars. We're going to pay you in hustle and experience. And we're going to work you 20 hours a day because there's another person who wants this job right around the corner if you don't want to do it. And it's just a sadness and misery factory. And people go like, all right, I'll make room scheduling apps if I can just make 40 times as much money and not have to work nights.
Yeah. Sounds about right.
Yep. Other questions about data modeling? All right, I'm going to throw a challenge out for you. This is hard, but one of the things I like about it is it's kind of like variable difficulty. I want you to attempt to model a library. This is a little bit of a trick because this is, in my experience, probably one of the most difficult things to model correctly. But we can start simple. You got books, you got authors. Why don't you try to start there, and then once you've got that, I'm going to start writing some corner cases. for you to think about. So we are model a library. And I want you to start on your own, and then I'm going to start kind of shuffling you into groups. Let's start on your own. Model a library. We definitely got books and authors. And I'll start throwing out some weird ones in a sec. Go for it. Wrestle with this a little bit. All right, I want to combine you a little bit, and I want you to share the work that you've done. See if you can work out with each other. See how many of these you can get through. So let's do table, table. Priscilla, why don't you join Gage and Joe? Table and table. Cool, go.
Yeah, it's I tried to change it midway through and I was like, yeah, well,
like kind of messy and it should have been through like one file, but I started writing it wrong basically. I have like this one that stores all this data. It's like, and I said books and books and libraries is million of each book and the members and million each book. Oh, it's really complex. I can't think they're explaining it very well.
I don't know, I was getting something last night. I feel like
I was wondering if we use like addition.
yeah, I think too far.
Or would additions just be an extension of book, like it's just another variable inside the book, so just more books?
Right.
That's true. That's why I kept it to more like books, authors, and library, and like the data that stores like things that all the data. And I said, these are all going. That's just how I think of it. It's kind of hard to explain to the person.
Like I can really
Yeah, I like the structure. I just have terrible handwriting and things like this looks way better. Can you read that?
That's how I usually write.
My mom showed my handwriting to a third grade class that she teaches, and they couldn't read it. It just shows.
Let's take another minute.
Yeah, I liked this kind of structure. This is how I think of it. So it's like all books. That's like, I feel like that's something that's stored within like this one with the book. Like it's something associated with the book. It's like a value that's like true for this. Yeah, exactly. It'd be like when you initialize it's like check validation policy, you change that with a method. It's like return or like just check validation. So like I know how it works conceptually, but the diagram is very so I could like draw it with like electronic pencil. Exactly. If I look at it, I'll understand. If someone else looks at it, like what the hell is this?
Yeah, I wonder like if these are all extensions off of this, but you're right, like if you wanted to search edition or authors. So I don't know if you can go.
All right, all back together now. So I saw some goodness out there. A lot of people got at least this first one, how we handle multiple authors. So if every book can only have one author, what is it? One what? One author has many books. There we go. All right. So we're starting simple. Book, author. We say, okay, well, one author has many books. And then Old Man Coberly changes the rules, and now a book can have more than one author. So maybe we make a book author or an authoring or something like that. And now take that one to many, turn it into a many to many. Cool. Different editions of a book. So when a book's edition changes, our rule is going to be, it's always the same authoring for this, but it might be revised or something like that. So we'll say that one book can have many editions. Okay. Multiple copies. So now we need to decide, what have we chosen that book is? What have we chosen that edition is? Do you have more than one copy of a book or more than one copy of an edition?
The edition.
Okay, why? Defend your choice.
It just seems like book goes to, like there's editions of books, but then there's copies of, so maybe it's like it's connected between, like copies could be connected to edition and book.
Interesting. So yeah, I've got a copy. Now I need to figure out where these arrows go. A thing I would caution you against is trying to make the relationship there and there. You don't need to. I know what book this is a part of because it's a copy of an edition, which is an instance of a book. I can find out the book that way. This doesn't need to have its own separate relationship. I can go back through the model to find that. Okay, somebody tell me what I'm drawing for copy. Many to many. Defend your choice. Like for addition and copy?
That was 1 to 9.
Okay,
Sorry, yeah, one, each edition has many copies.
I like it. All right, so one edition has many copies. And so I can say, all right, this particular copy is an instance of this edition, which is an instance of this book, which has the following authors. All right, is a book currently checked out? This one's a tricky one. Any ideas, Priscilla?
Well, I was thinking if there are several copies, they could each be checked out. So that would, there's only one checkout per copy,
Correct.
so 1 to 9.
Okay. What are the entities here?
Checkout.
Okay. So like an instance of a checkout. I like that. Now the sneaky part of this, so sneaky, is what other entity do we need? We have a copy of a book and a checkout. We're missing an entity though. Mohammed?
Book author?
Not necessarily, unless that book author is checking out a book.
Who checked it out?
Who checked it out? So maybe we got a patron in there. So we got patron, checkout, and copy. Priscilla, since you led us on this lovely road, any ideas of how we connect these?
I think the copy and the checkout is 1 to 1.
Okay.
I'm just going with the, but the patron can check out many books, if it's 1 to many.
Okay. Cool. Thank you, Priscilla. So let's sit with this for a sec. We have a copy of a book. We didn't really talk about one-to-one relationships at all, but one way that you can think of one-to-one is. Would the word is be appropriate for this? A copy of a book is a checkout. Probably not. So that's not the right one. Versus user and player. They say a user is a player. So one-to-one kind of makes sense there. It's a good guess though. And one patron can have multiple checkouts. That does make sense. So I think we can keep that. Anyone else want to take a crack at the relationship between copy and checkout? Yeah, Danielle.
You gotta make sure that the number of checkouts doesn't exceed the number of copies.
Ooh, thank you so much for bringing that up. Because a lot of that kind of restriction sort of stuff, that's logic. We want to keep very, very, very little logic in this. Other than defining what legal relationships are, Once we get to like, all right, this needs to be less than this or more than this or something like that, that's what we have Ruby and programming languages for. There's no ifs or loops or any of that kind of stuff in data modeling. So if we need to enforce constraints, 9 times out of 10, we're doing that with a programming language. That's a great point, though. We have a copy of a book and this checkout. Yeah.
One checkout can have many copies.
Interesting. So I think I see where you're going with that. Because like, hey, this is like my cart or something like that, and the cart can have more than one thing in it. But here we get to the vagaries of language. Really, this is representing an instance of a checkout. We might also have like an order that has all these individual things in it, but we need to clarify what we mean by that. So if we're going to say checkout is an instance of one thing being checked out. Priscilla, I see it. It's right there.
I knew you were on the end, but each copy can be checked out many times?
Yes. So that's probably what I would go with. Now, to do it the way that Colin was talking about, maybe we have an order entity that represents a collection of things being checked out. And so in that case, we might say, one patron has many orders. Each order can have many checkouts, and a checkout is an instance of a copy being checked out. Cool. This is the data modeling process. I would, almost as a blanket rule, recommend that you spend more time wrestling with your data relationships than you tend to as students. A lot of like during project weeks and shit, your Thursday woes are the result of not spending enough time on this on Monday. Questions about data modeling?
So where did the anthology?
Anthology. Anthology would be multiple authors, but one or a collection of editors. So that would probably be another thing up here. That would be something like editor. So one, but then you'd have another like book editor instance. Or it'd be something like that. So a book can have authors and can have editors. That's probably how I would treat that. And then we can get into, all right, the library doesn't just have books. What about audio recordings? Well, there's different formats, and now you have like different artists that can be a part of that. Maybe keep track of producers and engineers and stuff on that.
Each book would have many formats?
Yes. Yeah, audio book, print book. Do those count as editions?
Right, exactly.
Or do we have some kind of model for that? And another one for, it's the same book with different covers. So the most thorough attempt I've seen at modeling out what I call the library problem, so old Coberly standby, is about 150, 200 entities. You can go nuts on this. And I often like to. All right, any last questions about data modeling before we shift over to SQL? Yeah, Kate. T.
I know we haven't talked about databases
Yeah.
in and of themselves. Do databases have these relationships built into them, or is the idea to just sort of house the data and then the code actually builds the relationship?
So I'm trying to look for an appropriate thing. Here is a metaphorical baseball Thank you so much, Kate. That's exactly what we're talking about next. So these stupid. So in terms of databases, getting out of the abstract more into the concrete, you'd say that each of these is a database table, and yes, it does have a mechanism to enforce these relationships. Those do go along with the database. So that's what we're going to talk about next, but we've been in here for an hour, so let's take a break. Be back here in 5 minutes.